Welcome to our project. We are a team of 5 members from Hanoi, Vietnam. My name is Đặng Quốc Anh. My team includes me, Hoàng Nhật Nam, Lê Hải Châu, Nguyễn Trọng Nhân Nhân, and Hoàng Nguyên Giang. We are happy to participate in this competition. It's my pleasure to show you our product, the IoT Virtual Doctor. The COVID-19 pandemic has not only changed our world these days, but also has a big impact on the society. All frontline workers and those in direct contact with people who catch COVID-19 are at great risk. Minimize the spread of the pathogens and protect healthcare workers. Healthcare service has been severely restricted, which results in a big burden on the patients. Thanks to the advance of the modern technology, doctors have the opportunities to examine their patients through video call, but they still face many other difficulties. For example, the laptop and mobile phone screens are unable to be moved, so they cannot see the patient clearly. As a result, remote treatment and examination are very important and effective. Both can reduce the spread of the coronavirus, direct contact with patients, and also save the doctor time too. These are the reasons why we came up with this idea for the project, the IoT Virtual Doctor. Next, Lê Hải Châu will be presenting to you about the objective and the implementation process.
Good day everyone, my name is Châu and I'm going to continue working toward our objective. We want to build a smart robot that will allow doctor to spend less time physically interacting with patient. It can navigate the patient room and conduct medical examinations. This high-tech robot can perform a variety of tasks, making it a useful medical assistant. Because all data is transferred through the internet, it's easy for the robot to gain control over the entire system. Furthermore, the IoT doctor can function automatically, saving medical personnel time and effort. Medical staffs are well benefited because there is less need for direct interactions between doctors and patients. The risk of infection could be greatly minimized with this autonomous healthcare robot. The next step is the implementation process. We will make a list of everything we require for these robots based on the concept. We start by constructing the robot's case and electronic circuit diagram system. The next step in the process goes to design the robot's case and code each component. After putting the piece together, we have a working robot prototype. And finally, we finish it and test it to see if there were any remaining issues, and that's how we finish our product.
Hello, my name is Nhật Nam, and to continue our project, I will be introducing the robot's components. So in order to create a robot, we need to have a frame base like this. As you can see, our robots are 4 wheels. It should be attached with one DC motors, which is controlled by the DC motor drivers, the PTS 7960. There will also be a Wi-Fi modules, also known as the ESP8266, to help transport the communication data between robots and operators. Moreover, we also have sensors, both different sensors and infrared sensors, to help the robots with their automatic movement. The Arduino Mega is also the main controllers and control the whole system functioning as a brain. On the top, there is a tablet that allows doctors to look after the patients through the screens. And batteries, of course, will be used to provide robots with power. Meanwhile, wires and components will help to connect the power sources to the sensors, the motors, and the modules. In addition, doctors can also use a base IoT-based panels to control the robots. The control commands will be sent online and received by the robot controllers in real time so that the motors will be operated and achieve the desired movement.
After months of working, our product has satisfied every initial requirement, and throughout many real-field tests, the robot functions smoothly and got positive reaction from users. It allows real-time control and establishes stable connection even in enclosed buildings. The most innovative function of our product is to allow instant communication between doctors and patients. It can be controlled remotely using a computer, and the integrated screen provides realistic interaction for both patients and doctors. We also added an automatic sterilizing sprayer and some sensors to collect patients' health data like temperature, heartbeat, and SpO2. During the time when the world was in chaos because of COVID-19, we have seen the doctors to patient ratio getting lower and lower. Healthcare workers were always at risk of getting affected by their patients. But with the help of our robot, that scenario won't happen again, and doctors no longer have to expose themselves directly to the sick. As for now, our product has seems already well fleshed out, but we think there are still room for improvement. First of all, we're aiming to develop a navigation system using the LiDAR. So in case there is insufficient doctor at the hospital, our robot can do some basic tasks autonomously. Secondly, we want to upgrade and optimize the structure of our robot. This can be done by working on upgrading the design, replacing better material, and we want to use carbon fiber instead of aluminum, and increase battery capacity. Last but not least, we're planning on adding more sensors to help doctors collect information about patients' health condition. And that is the end of our presentation. We hope you like it, and thank you for your time.